Okay, so in the previous video we looked at how you move the character around. So in this one we're actually going to rotate the character so that the character faces the mouse position. The mouse is going to raycast against the ground inside here, and it's going to hit a point, and we're going to rotate the character to look towards that point. One of the issues that I can see potentially straight away is that our raycast might hit parts of this surface in here, and it also might hit off the top of the polygons that we haven't removed inside these tunnel areas right here. So let's cross that bridge when we come to it, and we'll deal with it. We might have to change the actual colliders and stuff, but we'll deal with that issue if it's actually an issue at all. Okay, so I'm going to go back into the player movement script, and I'm going to look at the actual update function, right? So this update function is doing a lot already, right? So it's got a lot of stuff going on inside here. So our velocity and our position, all that kind of stuff, and how we actually press the keys to make things move. Let's clean that up a little bit, right? So what I'm going to do is I'm going to define a function called void move. Oops. That is not supposed to happen. Void move. Right, that's all I wanted. Thank you, Visual Studio. So void move. And it is going to take all of this stuff. So void move is going to do all of that work for us, right? Okay. And then all I got to do inside update is say move. So if I'm pressing any of those keys, they'll be intercepted inside this function call right here. And then for the aesthetic and the look of our script, just save us going mad, we can just collapse all that until we need it again. So move has got all that stuff going on, and we're calling it every single update. Let's create another function now called rotate. And this is going to do all the fancy raycasting and all that jazz, and that's going to take care of moving or rotating our character to look towards a certain position. So a raycast, for those of you who don't know, is basically it's a method by which you can send an invisible line from one point in a certain direction or one point to another point to see if there's anything in between those 2 points. So if I wanted to say shoot somebody in a first-person shooter game, I could cast a ray from my camera position, which is effectively your eyes in the game, in a certain direction, and whatever that ray hits, I could then say, well, I've shot that. So if it hits a wall, I could play a ricocheting bullet sound. If it hits an enemy, I could determine exactly where I hit the enemy and do blood splatter or do physics and add impulses or just do damage in general. Okay, so that's what we use raycasting for. We also use raycasting for point and click adventures where you want to click on certain points of the ground and say move the character to here. Or it's used heavily in physics to determine what exactly which objects are going to collide with each other, and are two things in proximity, and so on and so on and so on. So we're using it kind of like in the point and click style, but we're going to say cast a ray from the camera position straight towards the ground where the mouse position is, and we're going to make our character look towards that position. So we need two things. We need a raycast hit, which is going to record what we actually hit. And then we actually need a ray as well. Ray is equal to, now what is this ray equal to? Well, this is the first thing we're missing. So at this point, our script is going to need a reference to our camera because it needs to know where the camera is and where it's going to cast from. So let's get a reference to that camera in here now. So if you create a public camera, it's also going to use the camera class to call a function which turns a ray which is cast in 2D space, or sorry, not a ray, a 2D mouse position into a 3D hit on a plane. Okay, so we want to say that the ray is equal to camera dot screen point to ray input dot mouse position. So this is going to figure out exactly where a raycast hit, something that has a collider. By the way, the thing that you want to raycast against must have some sort of collision on it. There are other methods of raycasting against meshes and stuff like that, but out of the box, you're going to be casting against colliders. Luckily, our Pro Builder world already has mesh colliders built into it, so they should work. And this is where I bring up the issue potentially where our ray could hit the surface or the top of the tunnel system because we didn't get rid of those meshes. So let's or those colliders. So let's have a look at that later. So this is going to cast the ray, and then we need to check if the ray actually hit something. So if physics dot raycast ray comma out hit. So basically what this if statement is doing is it's trying to determine, did this ray hit something? So if physics.raycast this ray, did it actually hit something? If so, then populate this hit with the information of what this ray hit. Okay? So we could say then, okay, if ray, well, that's interesting. So now we need to determine, well, what do we actually need to hit? Is there something we need to hit, like the ground or what? So what are we actually hitting here? It might be a good idea to examine the actual structure here. So if your level, for example, is always going to be flat like this, I mean, you know, you can't say that's going to be like that forever. Your game might change in design as you kind of develop it. So it might not be a good idea just to say, if it hits something, then we need to look in that direction. But for now, let's take the complexity out and see if it works. Okay. Yeah, it should be okay. Let's have a look. So if ray, or if, so basically this is saying if it hits something. Let's say where that point is. So let's create a vector 3 hit point. That's our vector 3 as a hit point, is equal to hit dot point. So this is the actual point where the ray hit somewhere. Then we need to say transform, which is the player that we're attached to this script, dot look at. So we actually make the object, the player object, rotate towards to look at the hit point. Okay. So there's probably going to be a little problem with this, but we'll deal with that in a sec. So we need to bring in our camera. That's a public camera right there. We also need to call this rotate function just after here. So let's call that in our update as well. So we move, it does all the movement, and then we rotate, it does all the rotation stuff. Let's go back to our player and look inside the script. Okay, now we got an empty reference to our camera. Let's, not the camera holder now, let's put the main camera inside there. So the child object, the original camera that we childed to this camera holder, let's put that inside that reference. And let's see what happens. Okay, so it's hard to tell. Yes, there we go. Look, our character is now rotating towards the mouse position, but you see that? That crazy stuff right there. So this is a problem that we've built in. My raycast is coming from the camera and it's hitting the ground at a certain point. That's all fine. And look, I can actually hit W and it'll follow. Now I'm holding the W key and the character will follow the mouse, which is kind of cool. And then you can also strafe left and right, which will kind of orbit the mouse position, which is great when you're shooting hordes of zombies or whatever, aliens or whatever. And W will move away, which is cool as well. But the problem is our character is looking down towards the point. And that's simply because the point is hitting the ground, but the player character, its central axis is actually at its midpoint. So it's orbiting and rotating around a point that's center to here inside the actual character. So it's looking lower than, when we get closer, it's looking lower than it is tall, okay? So what we can do is we can adjust this hit point so it's the same level as the character, which will make it not rotate anymore. So go down to our rotate function. Let's just say that our hit point that we created, hit point dot y is equal to transform dot position dot y. So it's the y value of this hit point is being changed to the same height as our character, and now it won't get that horrible funky rotation thing. See? So it's still rotating, but it won't try and bend over to look at the point when it's on the ground, which is really handy. And that's it. That's the player rotation sorted. So let's, well, we don't know yet. Let's have a look and see. Are we still? No, we're not. Okay, not too bad. Right, so it's actually casting the ray through the top of the tunnel, which is great. But we did have an issue there where we hit the side of the room, I think it was. So if I do here, for example, there, do you see that? When it hits here, we have an issue. Yeah, okay. So let's see. I don't know enough about these mesh colliders on ProBuilder to see exactly where we can actually define that. Let's see. If I click on here and go down to my mesh collider. Yeah, so it's actually taking the mesh itself, the ProBuilder mesh that we've created, and it's scanning it in here, which is a pity. The only thing I can do is to be really tricky and cheat. So when you're stuck, guys, you gotta cheat sometimes, right? So what I'm thinking is, we can actually determine what it is we're hitting in the mesh. Let's give everything a tag. So if I say that this level, because I've childed it, I can give that a tag. I can add a tag and I'll call that level. Well, that would actually defeat what I'm trying to do. It's probably not a good idea. I'll just tag it anyway. In the short term, I don't know if I have a solution for this. Let me think. Here's an idea. What I could do is say that I could ignore any hit point that is higher up than the player. That's what I could do. Yeah, so the player could always be on the ground. I don't want to say 0 because we don't know if our ground is going to change later on. But I can say that if the hit point is higher than the player, then look, it's probably something above them, right? So let's say if hit dot point dot y is less than or equal to transform dot position dot y, meaning if the hit point that we pick up from our raycast, if it is, you know, at the same height or less than our player's height, then we do all this stuff. So let's try that out and see if it fixes our problem. Okay, so yep, that's all good there. And if I walk through here, we raycast against that. Yeah, that's lovely. Okay, that sorts things out for us. Cool. So now that was the problem. So my mouse was here, right, and it was raycasting up against, potentially up against this part of the ceiling. So our player was trying to move back to that point, which was above it. But look now, because that is not lower or higher, it will actually deal with that for us, which is great. Okay, cool. So yeah, we seem to have gotten over that problem. Yeah, it seems that I could have left the ceiling on this particular room as well, which is, yeah, that might have been nice for certain lighting effects. Right now we've got this direction light switched on, which is almost like sunlight coming in. We're going to change that later. I'm going to turn this direction light off, and we're going to have kind of more of a nighttime, eerie kind of look. If we don't get the nice kind of lighting and bounce effects that I'm looking for, we could actually stick a roof or a ceiling back on this level, and we can do some cool stuff with that then later. Okay, thanks guys.